In today's class, we will discuss about some problem sums based on exponents and rationalization, which are of level 3. Now the first sum is in front of you. It apparently looks complex, but if we rearrange these terms this way, then we can easily simplify that. So what I have done here is 9 to the power x to the power 10. The power or exponent of 9 is x to the power 10, and that power or exponent itself is in the form of power or exponent. So 9 to the power x to the power 10, and then we have within this root we have x to the power 4. It's not square root, rather within that root we have this x to the power 4. That means we can write this as 1 by x to the power 4, and then with this term, this 6 to the power x to the power 6 is multiplied. So here we have this multiplication sign. So accordingly it has been written 6 to the power x to the power 6. So power of 6, that itself has again power. Now we have again within this root we have x to the power q, and that accordingly has been written as 1 by x cube. And then again with that we are multiplying this term 3 to the power x to the power 3 or x cube, and then we have within this root x square. So accordingly it has been written, then we have here again multiplication. It is multiplied by this term 2 to the power x, and then we have here within this root x. So accordingly 1 by x here, and then the whole thing we are taking the square root of that. So here we have basically 2, so the whole thing has been written, and then we are taking the square root, so 1 by 2. And now we will simplify this. So first 9 to the power x to the power 10, and here we have 1 divided by x4. So we can simplify this way, that here we will have x to the power 6, 10 minus 4, and then with that we have 6 to the power x to the power 6, and then we have 1 divided by x cube. So if I take only this part, this much, then we can simplify this way, that here it will have 9 to the power x to the power 6, and then we have 6 to the power x to the power 6, and then we have 1 divided by x cube, the power will be. And further it can be written as, since their exponents are same, so their base values will be multiplied. So it will be 6 9s are 54, and then we will have x to the power 6, and here we have this exponent 1 by x cube. So it will be x cube, and finally this value will be 54 to the power what? It will be x cube. Now what we can do, this much we have simplified, and that has come as 54 to the power x to the power q. Now what we can do in the next step, I will take 54 to the power x cube, and then this much, only this much, 3, and then x to the power q, and then we have this root which is 1 by x square, this power or exponent. So this much if we simplify, then it will be again the exponents are same, so base values will be multiplied. So it will be 54 multiplied by 3, which is 162. So it will be 162 to the power x cube, and then this power value will be multiplied as per the rule that we know. So it will be only x. So the simplified value will be 162 to the power x. Now if we extend further, means with this 162 to the power x, the next term if we multiply, which is 2 to the power x, and then its power is, whole power is 1 by x. It will be 3 to 4 then to the power x, and then we have this power which is 1 by x, which will be multiplied. So x will cancel each other, and this is 3 to 4 only. So finally it will be 3 to 4, and this the final power which is half, means square root of 3 to 4, and that value is 18. Now we will move on to the next problem sum where ABC, that product, is given as 1 and we have to simplify this expression. So since ABC is equal to 1, so we can write this way that A will be equal to 1 by BC. Then I have rewritten this expression which I will evaluate. So what we can do is here 1 divided by 1 plus, in place of A, that A can be replaced by 1 by BC, and then here we have b to the power minus 1, so that can be again written as 1 by b. So A, in the first term of that expression, A has been replaced by B and C, and in the second term we already have B and C, so here we don't have any A, so we don't need to replace that. So it can be written as 1 plus B, and then C to the power 1 means 1 by C. And in the third term again we have 1 plus C, and then we have A, and that is 1 by A. So if A is equal to 1 by BC, then 1 by A will be equal to only BC. So in the whole expression we don't have any more A, and the whole thing has been expressed in terms of B and C only. Now it will be easier for us to simplify. Now if we simplify the first term, the LCM will be BC. So it can be further written as, so since BC, so that BC will multiplied by 1, so first term in the denominator will be BC, then the second term will be 1, and the third term will be what? Here we have B, so the C will be multiplied with the numerator, so here it will be C, and then we have BC. So denominator of this denominator of the first term will be BC, and then plus the second term. Again if we simplify, then, and in the third term we don't need to do anything, so for the time being we will keep as it was, and then we will simplify further the first term and second terms, and there will be no simplification in the third term, so it will be again 1 plus C plus BC. I hope you have, by now you have already understood what is going to happen. So here again we will take the LCM of these two terms, so it will be 1 plus C plus BC, because all the denominator values are same for all the three terms. Now since they are same, so numerator values will be simply added, so that will be 1 plus C plus BC, and what we can see here is the numerator and denominator values are same, so finally the simplified value of that given expression will be 1. Hence it is proved. Now we will move on to the next problem sum. Again this looks same as the first one that we solved, but this will be easier compared to that. So again I have rewritten in this format the way I did for the first problem sum. Now here what we can do is 16 to the power 16, and then again in the power of that is half. So after simplification, you know that will be 16 multiplied by half, so it will be 16 to the power 8. Then we have 18 square, and then the power of that whole expression will be half, and then that is multiplied by 9 square, and then power of that whole expression is half, and that is multiplied by 3 square, and power of that whole expression is again half. And now we will simplify accordingly. So it will be again the power of this, which is half here of this expression, that will be multiplied by their individual powers. So finally the simplified form will be 16 to the power, here it will be 4, and here it will be only 81, and then 9 square, and then the power is half, and then 3 square, and then again the power is half. So if we simplify further, then it will be 16, then 9 means 3 square, and here we have half, so it will be 3. Then again for this 9, what will come out of that square root will be 3, and here we already have 3 square, so again it will be 3. So finally what we are seeing here is 16 is multiplied by 27, and that value will be 432. So that is the simplified answer for this problem sum. Now let's see what is waiting for us. So this is just a problem of rationalization. Here the first term, in the denominator we have 4 plus root 5. So if we rationalize this term, then the rationalization factor will be 4 minus root 5, and here in the third term we already have in the denominator that factor 4 minus root 5. And again if we focus on the second term, here in the denominator we have 5 plus root 3, so the rationalization factor will be 5 minus root 3, and that we have in the denominator of the fourth term. So what we can do here, for ease of this simplification, we can combine the first and third term and second and fourth term. So that's what has been done here. Now we will simplify further. Now if we take the LCM of 4 plus root 5 and 4 minus root 5 of these two terms, then it will be 4 plus root 5 and then 4 minus root 5, and 4 minus root 5 will be multiplied by another 4 minus root 5, so it's square. And same thing happens with the 4 plus root 5 also. And then in this part we will again take the LCM, so it will be 5 plus root 3, and here that will be multiplied by 5 minus root 3. Here 2 will be multiplied by 5 minus root 3, and here 2 will be multiplied by 5 plus root 3. Now if we simplify further, then it will be, now root plus root 3 and minus root 3 will cancel each other, and from the first term also 8 root 5 plus 8 root 5 and minus 8 root 5 will cancel each other. So the simplified values will be, from the first term it will be 16 plus 16 32, and then 5 plus 5 10, 32 plus 10 42 divided by 11, and from the second term we will have 5 plus 5 10, and then 2s are 20, and then in the denominator 22. So 22 will be their LCM, so it will be 84, and here it will be 20, so 84, it will be 104 divided by 22, so 2 is the common factor, here it will be 52, here it will be 11. So finally it will be 52 divided by 11. Now the next sum, here we have a series sum. The first, this factor, this term is given in that form, and that is equal to a minus root v, and we need to find the values of a and b. So what we can do is we can expand this series sum, because the value of k is given from 4 to 143, and that we need to consider. Every value of k should be considered. But if we go on putting all the values of k, then that series will be lengthy and it will take a lot of time to simplify. So what we can do is we can apply a trick. So as we can see here, this is given in the form of square root, so we can rationalize that, and for that the rationalization factor will be, for this term it will be in the denominator we have here plus, so that factor will be root k minus root over k plus 1. So in the first step we will multiply the numerator and denominator by minus here. So the rationalization factor is root k minus root over k plus 1, and we have multiplied both the numerator and denominator, keeping all other things, the limit of that k value, that series, and on the right side this is a minus root b. Now we will simplify this first, and then we will see what we can do more. So it will be root k minus root over k plus 1 in the numerator, and in the denominator what we will have, we will have root k square, means k, and then we will have here minus, and then root over k plus 1 square means k plus 1, and minus k plus 1, so it will be minus k minus 1. So we can directly write minus k and then minus 1. So finally in the denominator we will have minus 1, and this is a series sum, so the value of k is equal to 4, the lower limit, and the upper limit is 143, and on the right side that will be equal to a minus root b, and that can be further written as, since in the denominator we will have minus 1, so the numerator can be written as root over k plus 1 and then minus root k. So next what we will do is we will put all the values of k starting from 4 to 143. So first value if we put in this series, then it will be root 5, and then for k it will be minus root 4. Then the next value if we put, means when k is equal to 5, it will be k plus 1 root 6, so it will be root 6, then it will be minus root 5. Then the next value of k if we put, means k is equal to 6, then it will be k plus 1, so it will be root 7, then minus root 6. And this way if we keep on putting all other values of k, then the last term will be what? Last value of k is 143. So here the last term will be 144 and then minus root over 143. So this will be the complete series and that will be equal to a minus root b. This root plus root 5 is getting cancelled by this minus root 5. Similarly, this plus root 6 is getting cancelled by this minus root 6. Now in the next term we will have root over plus 8 and then minus root over 7. So this minus root 7 will cancel this plus root 7, and accordingly if we keep on moving this way, then this minus root over 143 will be cancelled by plus root over 143, which we will have just before that. So finally what will remain in that series on the left side is, for the last value of k we will have root over 144, and for the first value of k we will have minus root over 4. So these two terms only will remain in that series finally, and that is equal to a minus root b. So if we compare these two values in that equation that we have, then we can easily say that a will be equal to what? That will be root over 144. That means that value is 12, and then minus root b is equal to minus root 4. So minus minus will cancel each other, root will cancel each other, you can say, and b will be equal to 4. So our conclusion is, if we simplify this, then final value or the value of a will be 12 and the value of b will be 4. This was the last problem sum of this class. In the next class we will simplify a few more sums. Till then, stay tuned. Thank you.